Thank you for coming to the first Co-Integrate Math series this year. My name is AJ Edson. I'm helping to organize this series. We are really excited to have Kristen Bieda here. Her talk is University Teaching Experience, Early Field Experiences that Prepare Teachers for the Demands of Teaching Middle School Mathematics. Once again, we are thankful that you're here, and welcome, Kristen.
Thank you, AJ. Thanks for coming, everyone. So you might notice the picture that I've chosen. I am not like a Star Wars buff or anything like that, but I have a little story I want to tell before I get into the meat of the talk, and that it starts back in 2008 when I was a brand new assistant professor here at Michigan State in the Department of Teacher Ed, and I had been assigned, I was asked to co-chair a task force on rethinking the teacher preparation program. And the co-chair of that task force was Tom Bird. I know there's some people in here that remember Tom Bird, but it was as much as the workload of that task force was probably a little bit too much for a brand new assistant professor, it was really a beautiful opportunity to get to spend time with Tom. So Tom Bird is, as you may have gathered, he's an emeritus faculty member. When he was here, he did a lot of work thinking about the design of teacher preparation programs. And I remember in our conversations, something that we kept coming back to was the question of, what does it mean to be a well-started novice teacher? And I was really somewhat puzzled. I didn't have just a knee-jerk response to that question. I mean, a lot of people have been thinking about this question. If you think about the emergence of EdTPA type assessments, inherent in the design of those assessments, somebody's answering the question of what it means to be a well-started novice teacher and the kinds of performance expectations they have on those tests. Others have been thinking about, whose work is in the practice-based teacher education movement, have been thinking a lot about what kind of practices a well-started novice teacher will have. But for me, in today's talk, I'm going to be talking more about what kind of experiences, what kind of situations do prospective teachers need to be able to prepare them for the demands of teaching math in schools. Much like Yoda was preparing Luke for the demands of being a Jedi fighter, I also think of Tom kind of as this Yoda on my shoulder at sometimes, who's speaking to me and sharing his wisdom to me as a teacher educator. So I think a lot of people in here have a sense of what MSU's program is, but I want to make sure everybody understands how the secondary teacher prep program works here at MSU, because it's going to be relevant to different parts of the story. So when someone comes to MSU and they're interested in becoming a teacher, they actually aren't admitted to the teacher preparation program until they're in their junior year. They have to apply to the program. They have to have a certain level of GPA. They have to pass a basic skills test. But in their freshman and sophomore years, they take 2 educational foundations courses, TE 150 and TE 250, to give them a sense of what it is, what schooling is like here in the US and elsewhere. It isn't until their junior year, when they're finally admitted into the program, that they start to have field-based experiences. It occurs while they're taking a literacy course, and they are out in the field in a school classroom for just 2 hours a week. And that's largely an observation-based kind of experience. They do engage with students to do some interviewing and tutoring in that field experience, but it's fairly minimal involvement. Then they go into their senior year, and that's when their preparation as a secondary teacher really starts to increase. So, and one thing I didn't say, if you're in the secondary program, everybody, regardless of subject area, is getting a bachelor's degree in their subject area. So I'm in secondary math, so all of the students who go through the secondary math teacher preparation program are going through the undergraduate mathematics degree program while they're adding on these education courses. So they're in their senior year of their undergraduate math program, and they take then their first course in pedagogy of secondary math teacher preparation. I'm calling it Methods 1. For a lot of you, we know this as TE 407. So TE 407 has 3 components. It has a 3-hour seminar class that meets. It has a 2-hour-a-week lab. I'll talk about that lab in a second. And then it has a 4-hour-per-week field component that's in schools. And they visit schools with another peer student in their Methods 1 seminar. So that happens in the fall, and it's largely repeated, that same structure in the spring. The lab in the spring focuses more on issues and developing their understanding of teaching students with special needs. That includes bilingual learners. But they're in the field again for 4 hours per week. It's the same field placement as it was in the fall. So they're with the same mentor teacher, they're going with the same peer in their Methods 2 course. And then they have, this is now senior spring, they're completing, hopefully, their undergraduate degree, then they add a 5th year of internship. It is not a typical, 5th year program where after that 5th year they also get a master's degree on top of it. It's just a 5th year, full year internship. So instead of a 16-week student teaching, it's a full year in one classroom with one mentor teacher. As in addition to that experience, they come to class on campus for 10 Fridays each semester, and they take 2 courses when they come. One of those courses is an additional methods course. So they do that each semester of their internship year. So in total, they have had 4, a concurrent sequence of 4 methods courses in their subject area, and then they have that full-time placement in their internship. So it's important that you kind of understand how the structure works as I'm going along. So does anybody have any questions about the general structure of the activities in our teacher prep program? Everybody's good? Okay. Yeah.
Is it significantly different from the other schools in the US?
Yes. So especially in that 5th year internship program, which gives us then the opportunity for additional methods courses. There are programs that may have 2 to 3 methods courses, but the amount of field experience they get and then that full year internship is significantly different than other programs.
Thank you.
Yeah. So I said I was going to talk about this senior fall lab. So back in 2008, I was actually teaching, in addition to working on this task force, my first class I was assigned to teach was this Methods 1 course. And I admit, it took me a while to get my head around all of the components. I'm looking at some of the other methods instructors because they know what I'm talking about. It's a lot of class. And one of the things at that time that I had a hard time really understanding was this lab, because at that time it was called micro-teaching lab. And students would work together in pairs to prepare a lesson and then teach it to their peers. We would assign 2 of the peers in any given class to do a little bit of background research on the topic of the lesson so that they could play like they were authentic middle school students, and based on their understanding of the research done on student thinking in that topic, they could interject certain naive conceptions that came forth from the literature on that topic. So there they were teaching to their peers. Sometimes their peers would throw in these little zingers of to try to stump them, that sort of thing. But I really walked away from, even in 2008, from that experience, wondering what students were getting out of that lab. So now fast forward to 2010, it was my 3rd time teaching Methods 1. I had received an MSU Lilly Fellowship to do a project to improve the experience in the field placement. And I decided, we need to tweak this because we've improved the work that they're doing out in the field. What can we do differently in the lab? So I asked my students, I said, what do you think about this lab experience? How do you think it works to teach to your peers? What do you think you get from it? And I was shocked to learn that what had been going on was that the students who had been selected to play like their authentic middle school students, they had been colluding with the teaching pair during the week before they were supposed to teach and say, hey, I found out that students tend to think this way, so we're gonna say this, during the lesson, we just want you to be prepared for it. So I was just like, why would you do that? So that's really that's the hard part of teaching, right? Is to have to deal with student thinking in the moment. Here we are in this really safe space, all of us are around, we're trying to learn to teach together, and you're trying to cheat the system in a way so you don't have to be put on the spot. I really wrestled with that, and they said, but it's different teaching to your peers because they kind of have the student hat on, but we know they also have their teacher hat on. We know that they're also watching how we are adapting and the teaching moves that we are doing, because they're going to see how we're taking what you're talking about in seminar and applying it to the lab. So that was their experience, and pretty much it had turned into a learning opportunity just to see if they could kind of play a role, and they had a certain kind of script to follow. So I knew that something needed to be changed before I went on. Sorry. I had one more thing to my story. So at that time, I remember talking to Joe. Joe came to me saying, I've been hearing about this Math 1825 class. And do you think that there's anything, what do you think about it, basically? You asked me what I thought about it. Because Math 1825 is a developmental math class on campus. It's taken by between 800 and 1,000 incoming freshmen each year who have placed into the course. They take a math placement exam, and so they've received a score that's below the level that they would need to enroll in college algebra. And when they enroll in the course, Math 1825 is actually an online course, a fully online course. The online component is the ALEX software system, which is a computer adaptive kind of tutoring module. So they take this online course and with the hopes of passing the course so that they could go into college algebra. As it turns out, it's a non-credit bearing course, so you don't actually get credit for it, but you need to pass it to be able to get into college algebra, which is the required course for many of our majors. Now we have the quantitative literacy courses, which is kind of, has it replaced 103 yet for some majors?
It has for some, but at this point at least, it still requires placement in 103, so students will still be 25.
Okay. So Joe's talking to me about this, and he's saying, do you think this is a good model? Like, is there something that maybe some reform that we could do to better support students so more students pass it? It's obviously a critical course, because if you don't pass it, you can't get into that credit-bearing course. So that's when I started thinking about, I wonder if we could replace the lab component with some sort of experience of having our students work in that course and improve the pedagogy of the course. So that's what kind of got us into this new model. And I'm going to skip some of this for now. And that's just got us started with the team project, which entailed having the students who are in Methods 1 work with that undergraduate developmental math course in their field placement. So 1825, I said, was fully online. So where were they going to work with it if it was fully online? As it turns out, for about 200 of the students who take 1825, they're advised to take this face-to-face seminar class, which is an enrichment kind of support, math support seminar. That course is called Math 100E. It's offered face-to-face twice per week. At the time, and it's continuing with the other sections that we're not working with, the instructors for that course are undergraduate teaching assistants hired by the math department. And they're provided materials such as problems to do with the students in those meetings, and then they can do tutoring in ALEX with the time that they have in those seminars. So we worked out with the math department to take over basically one of the sections of Math 100E. And the students who are in Methods 1 would be teaching in that course. So I've been calling it the University Teaching Experience, because it's no longer a micro-teaching lab. They're not just teaching to their peers, they're teaching full lessons. It is a very immersive teaching experience. As before, they plan and enact lessons in pairs. They rotate a new pair each week so that given the size of our program, it works out that each pair teaches at least 2 lessons in the course during the semester, while other prospective teachers observe. So this is a real-life course being taken by real-life students, right? It would be a problem if we just let the prospective teachers who've never taught a course before ever just loose, basically, in this course to see what would happen. So we decided to add in a couple of controls to make sure that the quality was sufficient so that it would be a good learning experience for the developmental math students. So math ed faculty and graduate students provide coaching through both lesson planning work, so prior to having the students they meet, actually they get feedback on 2 rounds, 2 drafts of the lesson plan before they go in to teach. And then they get in the moment coaching during instruction. So part of that is, which doesn't happen very often, if there's some incorrect mathematics being taught, or if it's just going off the rails and it's chaos in the classroom, it is good to have the coaches there to kind of step in and straighten things out. Like I said, it doesn't happen very often. Mainly the in-the-moment coaching looks a lot like pulling the prospective teacher aside during a small group work time and whispering in their ear, hey, I think you should go check out that group. They've got an interesting idea they're working on, or I think this group is really struggling. That kind of coaching to keep the momentum of the lesson flowing. Then we also added in a support of providing a debrief experience after each of the Math 100E course meetings, where the prospective teachers that had taught as well as the observers gather to talk about the lesson and give an opportunity to kind of unpack the experience that had happened. So that's the basic model. It has went through several iterations, and I thought it might be interesting to you to hear about and think about the different iterations that we've done. So we started this, we piloted it with some funding from the Dean of the College of Natural Science back in fall of 2012. At that time, what we did is we had our group of Methods 1 or T 407 students. We split them into 2, and we assigned one group to one section of Math 100E that met on Tuesday morning, and one section of Math 100E that met on Tuesday afternoon. So 12 students went to each section. Then the Math 100E students, sorry, this is a bit misleading, but the Math 100E students went to their respective Thursday session, whether they took it in the morning or in the afternoon. They went to their respective Thursday session that was taught by one of the undergraduate teaching assistants that the math department had hired. So we were really only involved in one of their sessions per week. There was still there's still coaching by the math teacher educators. And we had also, I didn't mention this before, but we really reimagined the curriculum for this 100E class. It wasn't just about taking some examples, working them on the board, but we actually designed, pulled from different curricula to design some lessons so it'd be more inquiry-oriented, students would be working in groups on high cognitive demand tasks. And I'm going to show you one of those typical lessons that we teach in a minute. So that was all here. And then for the debrief portion, all of the students who were in TE 407 would meet on Tuesday afternoons after this session. They would debrief for an hour, and they would have their seminar on a separate day, usually on Wednesday afternoons. So that was the first iteration in the fall of 2012. What might you imagine the problems would be with this design? I know Raven knows and Beth know them all.
There's a delay, it seems like, between the class and then the time that they're provided that they're given to provide feedback, so there's a potential there, I guess, for...
Especially for the Tuesday morning group, yep. There's definitely a delay. So the engagement and the debrief and trying to debrief both classes at once was tricky. Any other thoughts?
Did they collaborate with the undergraduate instructors?
Oh, you're asking, did we collaborate with the undergraduate instructors of this session?
Was it just like two very distinct sections, or was there some sort of back and forth?
Well, we tried. So we had the undergraduate instructors attend our sessions so that they could see what was going on. But we didn't necessarily have, that didn't translate into now a different kind of teaching practice in their session. They stuck very much to the script that they had been given when they were hired by the math department. And I would say that it caused an issue, I think, for the students in that they were not only, they were getting a different kind of instruction in that session, and it was very much kind of, I'm going to tell you things, I'm going to tell you the answer, which is not what we were inclined to do when we were working with them on Tuesday. And so then it put the instructor in a really strange position. The students couldn't decide really how they were supposed to, what they were supposed to be learning and which session they were supposed to be, kind of engaging with. And so it made it very hard to get them kind of into and buying into what we were doing in the Tuesday session. So then we changed it. We said, let's just work with one section of Math 100E. But we will work with, we will have the students coming both, we will split them so one group comes in Tuesday and one group comes in the Thursday session. So it's one section of Math 100E. And we had total control then about their experience in their 100E class. We still had the coaching. This time, although the coaching was getting better and better as we were getting smarter about how to do it, we were still continuing to develop the curriculum. We were largely using very much the same tasks, but one of the changes we made at this point was with our lesson planning. We had decided to adopt what I said was the kind of the two-stage model of lesson planning, where students were doing some more intense work on the mathematics of the lesson and the tasks that they were assigned, and they would meet with the math teacher educator and kind of unpack the math, and then they would plan the lesson. So that was implemented at this point. And at this point now, we have funding from NSF in fall 2013. Then we, instead of having the seminar on one day, we actually put the seminar across 2 days so that we could, on this Tuesday afternoon, we could have the debrief immediately afterward as part of the seminar portion. And then we would add on another hour to 2 hours for seminar work that is typical kind of methods course work. And then we did the same thing on Thursday. One thing that's important to note is when we do this, then all of the students are attending the debrief of each class, so that the students that teach on Thursday could see what had happened and could hear what had happened in that Tuesday session. I'm pausing just in case there are any questions as I move through. We now have even an additional iteration in fall 2014 where it looks largely the same. We still have them going in one section, Tuesday and Thursday, still the coaching, still the curriculum. But instead of having the seminar attached with the debrief, we just added a roughly 1 hour portion of debrief after each 100E class. All of the TE4-7 students were coming to those debriefs, but then they also all came to a separate seminar class on Wednesdays. And this is largely how it has stayed. I'm looking at Beth. Is this what we're doing? Because I'm on sabbatical this fall. Is this largely the model?
Yeah.
Yeah, okay. All right, so that's the model. Any questions about the model? Yeah.
Can you describe the inquiry-oriented curriculum just a little bit?
That is a very appropriately timed question.
Okay.
A typical lesson. That's exactly where I was going. Okay, so as I said, we were pulling tasks from different curriculum. They largely were NSF-funded curriculum that were standards-based. So this one comes from the College Prep Math series. We've actually taught this particular lesson since fall of 2012. It's been one that has stuck with our course pack for a while. So this is where students explore rate of change, specifically linear rates of change with motion detectors. So they start out having students get in groups, either paired up or in groups of 3 or 4, and give them a motion detector, and they have to experiment with determining of the equations of 2 lines that are walked by a group member. So they'll set a motion detector up, one person will walk away from the motion detector, and that will give them a graph on the motion detector. They generate an equation to model that graph. And then they do it again, walking towards the motion detector at a constant rate. And then they can plug their equations in and check whether or not the data that they get from the equations they created matches what they did in their experiments. So that's the first part. There's a follow-up part where we give them equations of lines and then see if they can walk those specific lines. And then the next part, so this is all happening in one class. They consider the following graphs. After they've had all that experimentation with the motion detectors, now they have to really think about, okay, for these cases, why would it be impossible to generate these with the motion detector? It's getting at their understanding of undefined slope, also these kind of piecewise functions, how you wouldn't be able to create that if you were, walking at a constant rate. Questions about the lessons? So it's the kind of thing where students are working together in groups, and they're not, I think what's really important about the curriculum, which I'm looking at Marie Posey over here because she and I have been working on some connections between the chemistry course and this Math 100E course. It's really important that students don't think that this is just like what they had in high school, because they've already had Algebra 1, they already had Algebra 2, and now here again they are in an intermediate algebra course, but they're in college. They have a certain notion of what they think college math should be. So the advantage, especially with a lot of this NSF-funded standards-based curriculum, is that it's embedding, I think, fundamental concepts in interesting contexts. And in this case, they're engaging with technology, and they're asking them much more challenging questions than, we could just say, graph those lines. They've done that before over and over, and they've had the same kind of issues with it, but having to physically, there's embodiment here, having to physically walk the lines and getting immediate feedback from the motion detector is developing a new, deeper, richer conceptual understanding for students. Okay, so I was going to show you a clip, but I don't think I have time for it. I'm just going to go ahead and move into what have we found after doing this now for several years. When we proposed the project to NSF, we basically had 2 questions we were interested in. One was, does this kind of model work for developmental math students? Certainly we weren't going to be able to keep doing this. I think no one would really dispute that it was likely probably a really good experience for teacher candidates. They're immersed in authentic instructional situations. But are we immersing them in a situation at the detriment of the students who are taking our course? That wasn't going to be sustainable. So we needed to see what the developmental math students were gaining from this. So this data, I believe, is from fall 2014. So this is the pre-measures, the couple of pre-measures we collected. One was their placement exam score, and one was the pre-score on the ALEKS test. And interesting, I was just at the University of Delaware. They don't use their own math placement exam. They actually use this ALEKS placement as their placement exam. And I'm going to show you data in a little bit that suggests that might be an interesting move for us to switch to. The groups here of our study, we were looking at basically 4 different groups. Group 3 is our section, the students who had taken our section. Group 2 is a set of students that were taking the other Math 100E sections. Group 1 is a group of students that's only taking Math 1825 online. And Group 0 are students who are taking Math 1825 but in other programs such as Lyman Briggs. Those classes are different because they don't have the online ALEKS component. They're taught entirely face-to-face. So we separated those out from the other groups. So what you might notice here is on the math placement exam score for this particular semester, this is a little fuzzy, but Group 3 was the highest, but on their ALEKS pre-score, they were the lowest of all of the groups. So that was the look at their pre-score measures. Now this is their post measures. So here's the 2 post measures here are final exam and their ALEKS gain, which ALEKS gain is the difference between, correct me if I'm wrong on this, Raven, the difference between the topics that they had mastered on their pre-measure and then the topics mastered at the end of the course sequence. That sounds right. I think so. So the final exam score, Group 0 was the highest. They had also received entirely face-to-face instruction. And in the case that I think the Lyman Briggs section, I think it's 5 days a week. Group 3 was the highest of the 1825 only and the other Math 100E sections. They had the highest ALEKS gain. So in looking at these post results, we were seeing evidence that it was at least doing as well as the other sections were doing. So we didn't see strong evidence that there was any reason that they were getting a...
Before you flip.
Yeah.
One thing interesting about that is the standard deviations are the smallest for Group 3.
Thank you for pointing out.
It's a very small n, but still, it's more compact.
Yep. Yes, thanks for pointing that out. Yeah, so we're not seeing evidence that they are having any detriment. And I also think that, like if you look, our n's are so small. So this was just 1 year of data. It actually took us doing this for 3 years or more to have enough data that we could start thinking about doing some matched sample analysis. So unfortunately, it's just not ready. I wasn't able to share that with you. But this was the trend that we saw all 3 years. The same look at the data, the same kind of results that our students, in some cases, were starting out further behind, but they were attaining at the level of the other sections, and in some cases, surpassing the other sections. The one thing I haven't put together, but I don't know, Raven, if you want to say anything, when we combine Group 2 and Group 3, we see those significant effects. That being in a 100E section leads to significantly, positive gains in their post scores and their final exam score and all of the post measures. So it's really critical that they get some face-to-face experience. This, though, I think is one of the most interesting things that we found. So this is showing correlations between some of the pre-measure data we collected, the placement exam and the ALEKS pre-score, and then the post measures, the amount of time they spend on ALEKS, their final exam score, the course grade, the ALEKS post score, and the ALEKS gain. So shouldn't be too surprising that there's pretty strong correlation between the final exam score and their course grade. But what you may notice is there's virtually no apparent correlation between the placement exam score and any of the other measures. There's a little bit of weak correlation, very weak, between their ALEKS pre-score and their final exam score, and of course their ALEKS post-score. But I think it's really key to note about the effect of the placement, or lack of any sort of effect of the placement on the resulting post measures.
Or even the resulting pre-measure.
Yes, yes. And I know, Limery, I think in our discussions, you looked at some similar data with the results of your Chemistry 121 students, and there were no correlation or weak correlation with the placement test score.
There really wasn't a correlation with the math placement score. There was a correlation with their math ACT score.
Yeah, which is, we don't have their ACT. We didn't look at that, Raven, did we?
We didn't look at that, but we do have it, I think.
I don't think we looked at
We
it.
have.
Okay, so we were relatively confident that this was a good experience for the developmental math students. I think there's always ways that it could be improved. But the other question that we said we would look at when we proposed the project was, what does this intervention offer for the development of the prospective teachers as math teachers? So it's important to note that we weren't thinking that in this one semester we would take somebody who's a complete novice and turn them into this amazing, ambitious math instructor. It's just, that wasn't our goal at all. We were interested in whether we could see growth in ability to maintain the cognitive demand of tasks, growth in ability to attend to student thinking, as well as some development of understanding of the obligations on the role of teacher, like how complex teaching is and what you have to consider when you're trying to enact these practices. But I think it's also important, as I said when I was telling my story, if they don't perceive this situation, this experience as valuable for what they're learning, they're likely not getting much from it. So we wanted to know what were their perceptions of the value of this experience for learning to teach. So to investigate their sense of the value of it, we interviewed prospective teachers in late April, May of their senior year. So this is at a point they've had the UTE in the fall, and they've been doing their school-based placement throughout for 4 hours a week from October through May. So we were interested in hearing from them things like, can you describe to me what you did, at that time we were calling it micro-teaching, what you did in the experience in the fall, what aspects of the experience did you find useful? Are you seeing things in your placement classroom that are similar to things that happened in 100E? What are the benefits and drawbacks to this experience compared to your field placement? And did it influence your work in doing things in the placement classroom? So I'm just going to highlight some findings to this question. What aspects of this experience did you find useful? So their responses to that question fell into 3 large categories that are very unsurprising. They learned about teaching skills. From doing teaching, we would expect that. But most of the discussion around teaching skills was focused on leading discussions, which is not something they might have an opportunity to do in their field placement. Many of us who've been in classrooms and do research in classrooms don't find a lot of discussion happening in those classrooms. So it's interesting that they're having lots of opportunities to build, or they're saying they're getting lots of opportunities to build discussion-based strategies. Other comments were about comfort, mentioning things like gaining confidence or feeling more comfortable. And then they talked about learning about lesson planning. Also not that surprising. It's their first methods course, and we focus a lot on planning to teach high cognitive demand tasks. So here's a table that shows our overall findings. What we did is we took the categories of teaching skills, comfort, discussion-based strategies, and lesson planning, and then looked at when they were saying they were getting those opportunities in the UTE. Was it when they were doing the teaching? Was it observing peers when they were actually doing lesson planning? Peer feedback, getting instruction or feedback from the math teacher educators, or on their lesson planning? So a couple things to highlight here. The vast majority of things they say they're picking up from doing the teaching, not surprising. And they also are mainly saying they're picking up various teaching skills. But a couple of things I thought were interesting in looking at the data. They learned a lot about discussion-based teaching strategies, they said, in doing the teaching, but they learned most about teaching skills by observing their peers, which I thought was interesting given that, again, in the field, the only person they're watching is the mentor teacher, or they might watch their peer. But having that experience of observing others throughout the semester seems to be influeing what they're taking about teaching skills. Also, in terms of the discussion-based teaching strategies, they're pulling a lot from their instruction, the on-the-spot, in-the-moment coaching from the math teacher educator. So here's a couple of quotes from their responses to illustrate. So this student says, in my placement class, I don't think the teacher would have stepped in unless it was like a train wreck. But here, Kristen, that's me, or the TAs in this experience would be willing to step in for smaller things. Just like, hey, think about this, or whisper in our ears. So I think what's really telling about this, and something that I've wrestled with in other work I've done with field placement, is that mentor teachers have one responsibility, and that is to their students in that placement class. That's to the math instruction that they're getting. They aren't necessarily always prepared to be teacher educators. And so having them take on that role may often mean they're struggling with when to give feedback, how to give feedback. Whereas in this experience, there's math teacher educators that are working with them and attuned to when to give certain feedback, because our focus has to be both on what the prospective teachers are learning as well as on what the developmental math students are learning. This student also, this is one that we coded as learning from peers. So I learned what to do and what not to do, and there were a lot of techniques that I liked that they did, and I even did in my placement. Like, I know one time my friend, their peer, sat down in the students' chairs as they were presenting and acted like the students, and I really like that, so I've done that in my placement. So a couple of other things that we've noticed about the shaping of the beliefs about learning to teach. One of our students who did this experience was also teaching one of the other 100E classes. And this has happened actually many times over the years that we've done this. And in this case, the student said during the interview, I wish my students could have had this class. Students in this 100E section learned way more than my students did, which I think is very, very interesting. And especially in this student's case, because they started out very uncertain about the value of the experience for the 100E students. I think, though, one of the most important findings for the use of this in teacher ed is that students saying things like, I realize that it's important for me that my future students don't end up in 100E. They took away that they need to learn how to teach well so that their students don't end up in the class when they go to college. I wanted to share a little bit. I didn't have a chance to talk about this framework, but I wanted to share a little bit too about how the kind of dilemmas that they're facing in this initial early field experience that replicate a lot of the kind of dilemmas they would face out in the classroom. So here's a case of where they're getting real experience in that tension of dealing with individual students' needs and addressing the needs of a classroom community. So this comes from a reflection paper that the prospective teacher wrote after viewing their video of the their 100E teaching. And they noticed that they spent too much time in group work and not enough time discussing the group work. Some of the groups who had finished early would become noisy and less engaged. I also realize now that you do not need to finish a problem with a student while they are doing group work. It's better to get the students started on the problem so that they can finish their problem on their own. Then any difficulties they had will come out in the discussion. So this is, again, I think, evidence that not only are these authentic instructional situations that they're dealing with, but also we see in their problem solving about what they would do differently, they're trying to address the multiple obligations that a teacher has to manage. They're not going to go get rid of group work. They're going to figure out, well, what if I just get the students started and I can actually step away from that? And they've had that lived experience, which is different than if you've just read a case about a teacher doing this, or you've watched your mentor teacher. You've actually lived that experience of having to deal with that tension.
Kristen, are all the lessons videotaped?
Thank you. Yeah, I didn't mention that. So yes, all of the lessons are videotaped so that the prospective teachers can watch the video of their instruction and then reflect upon it. Another tension which is very common is addressing students' individual needs while also upholding disciplinary standards. This is I think the math teacher educators in the room would recognize this is such a common dilemma. So in this case, the prospective teachers had planned the lesson, but when they planned it, we really only found one way to get the correct answers, and they came with finding correct equations. You could tell at times, though, that we were a bit shocked by the students' responses. I feel that if we had spent more time working on the problems ourselves and trying to come up with other possibilities of answers, that it wouldn't have taken us by surprise. So that's, I could have said that till I was blue in the face in my methods course, but it's another kind of experience that I think really changes practice when you realize that, and then you can, you've had that, again, lived experience. Finally, this one I think is important because they are having to grapple with the reality of this particular context with this particular group of students. So this student responded, they're reflecting upon a whole class discussion they had led, and they said, I proceeded to start the conversation by asking who was confused by the no solution for the second problem. I will never start a class discussion like this again. No one raised their hand and the conversation went nowhere. So on the face of it, we might expect to see the teacher start by saying, who is confused? But in this class, that's a problem. In a way, that may be positioning students so that they don't want to respond, because this is, again, a non-credit bearing developmental math class. So the assumption, I think, by a lot of people is that these students really don't know much about math. So we should expect them to be confused. And showing confusion is not something that they want to do. That conversation starter, if it was in a higher track AP level class, may not have elicited silence. But in this class it did, and I think it's important that they recognized how these students in this context react to that kind of conversation prompt. So overall, our outcomes, we're finding that they're experiencing authentic instructional situations as evidenced by their reflections on the work. It opens up questions about practice that really aren't there without it. We don't have some of these dilemmas. Perfect example, in the micro-teaching lab, if a student would have asked, who's confused by this problem, their peers would have raised their hands because they didn't want to leave their fellow peer hanging at the front of the room. They would have responded to that. But they learned about how to open conversations and how to start discussions in a group of actual learners and the kinds of rhetoric that you should use. It also motivates, we're finding, they keep saying, I need to teach well so my students don't end up in this course. So it's motivating the need to learn to teach well. So what are we still working on? A lot of things that still kind of confound the work with this model. So this pair rotation issue is challenging relationship building with students. So every week or every session they have a new pair in front of them. They may see that same pair later on in the semester, but it's a new group of teachers. And as much as we try to aim for some coherency in the kind of instruction they're getting, it's still new people each time. Really that continues to be an issue that we're wrestling with. Part of the pairing up has to do with just the size of our cohorts, but they've stabilized around 20 students. So in a 16-week semester where the first few weeks are modeled by the TA, we still have to pair them up so they get enough teaching experience. We also, with the curriculum, face obligations to prepare students for the 1825 exams. We can't just decide to teach the developmental math class that we want to teach. They ultimately have to take these 1825 exams and do well on them. So the organization, the scope and sequence of the curriculum, we have little control over, and that continues to be a challenge we're working with. We're still also refining the coordination with the methods seminar class. So the first, I talked about the different iterations we had. Sometimes the seminar followed right after the debrief, and sometimes it's a separate class. And our external evaluator for the project has offered a lot of great suggestions for how to better integrate the work they're doing in the seminar with what they do in the UTE. One of those suggestions, which we implemented in fall 2014, was to give the pair that's teaching the next session an opportunity to try out the launch of their lesson in the seminar class. So that is helping with some of the integration, but I think more could be done. All right, so I do want to, a lot of this work was done, a lot of the analysis was done by personnel that were on the project. I want to acknowledge my fellow co-PIs who are here today, Raven and Beth. And yeah, that's all I have. Questions?
Given your findings about things like the placement exam and that kind of thing, is the math department also treating this as educative to decisions they're making?
So there's been a lot of talk about where 1825 is going. I know that there's definitely a sense that 1825 may not be here long term. I don't want to say that they're going to eliminate it next year, but that's definitely the thrust of the conversations around this class, is trying to get to a point where we could eliminate 1825. There haven't been very many conversations about the placement exam, but I think that it's just a matter of time. I think it's really important that we not give up on it, because there's a lot of data showing that in this case it doesn't seem to be correlated to any of the exit measures, and that's a concern. I also, having come back from the University of Delaware where they switched, I think looking at other math programs that have some evidence of having made that switch and what they learned from it would be useful to share with the math department.
Is this sustainable without external funding?
Yes. In that we have had a lot of cooperation from the math department and to offer the financial support so that we can have enough math teacher educator support for the course. So really, what's the expense actually comes from needing enough math teacher educators in the form of graduate TAs to provide that coaching and to be there at each of the meetings. One of those is automatically built into the budget of the seminar, the TE407 seminar course anyways. The other one had been, that other TA line had been funded by the project. Now, both Prime and the math department are co-sponsoring that line with the hope that, I think we're ramping up to maybe having that be, university funded as a hard line in the salary.
Have you had any interns reflect back on the course after they've been?
Oh, that's a great question. And we are currently working on a proposal that will entail having other teacher preparation programs implement this model. And one of the things we want to do is do more longitudinal work than we were able to do. So we really didn't follow students out into the field and then ask them about, how they think this impacted their work in their internship. But that's a great question.
So how many students are in 1825 that take your course? Was it 14?
That semester it was 14. It fluctuates, but it's usually, we've had 20, we've had 24, so it's around that range.
So this goes back somewhat to Raven's question about sustainability, but also scale. Mm-hmm. Like how you said there's 600 kids in 1825.
More than that.
What's the potential of any kind of scale?
I think there's two ways to think about scale. One is we can take the curriculum that we've developed and scale it to other 100E sections through professional development for the other undergraduate TAs. So I think there's potential here in scaling the curriculum. That would be fairly easy to do, especially since the math department now has this Center for Instructional Mentoring and their dedicated staff that work with instructors in the math department. Now, the other issue of scale is as I said, I'm looking at a proposal to scale this at other teacher preparation institutions. So that's one way to scale. But ultimately, it's very difficult unless we moved the model to a different semester in the program to put, it's their first methods course to then take each one of those teacher candidates and dump them in a section and scale that way. I think probably what would need to happen is we need to just be a part of the professional development work and have the curriculum scaled with other 100E sections. Does that answer your question?
Is it possible along those lines to use the senior year's fall folks for the people who have been in that program, who participated in the first round as juniors, right, to come back with a greater sense of independence as part of their senior year TD program?
Well, so let me throw this back up again, just because it is kind of hard to keep track of the sequence. So this lab happens their senior fall year. In their junior year, they're only taking the literacy course.
Okay, so I'm sorry, I misunderstood. So these folks are seniors?
They're seniors.
Okay.
Yeah, and unfortunately, they're going on to the internship and they all get scattered, so there's really no way to kind of integrate them in the senior year. But we've thought about a lot of different things. I've wondered about the field placement work in the junior year, and could this somehow be coordinated with that so they're getting different kind of field placement? The field would be here at MSU, but maybe it could be moved into this junior year. The struggle though is they get a lot of support through the methods seminar for lesson planning that they're not getting. Something I didn't mention is a lot of our students in secondary math have taught this 100E class before they even start their methods work as seniors. So they've been the instructors who have, just worked through the examples provided and given tutoring, and that's been their work as TAs. So then when they come to our lab in the senior year, they're like, oh, this is not 100E, this is not what it should be. They come with a lot of resistance. And it takes a while before they start to see what a difference this is making for students' understanding. And that's, that was why we have quotes like, this group got a lot more out of it than mine did. They weren't thinking that going into it, but they leave thinking that way. Other questions?
Kristen, do they go back to their traditional field experience during the spring semester?
They are actually doing their traditional, their school-based field all the way through the senior year. It's a massive undertaking for these students. It's a big change from they had been a math major, taking their math classes and taking TE 150 and 250, and then they come into our class, and suddenly it's like a class that has this 3-hour seminar meets once a week, plus lab that they have to attend twice a week, plus their field component. It's a major shock to have to organize all of the different components. It's hard for the instructors too. Other questions?
Thank you, Kristen.
Thank you.